Hey, check, check, 1 2 1 2. Can you see me and hear me okay? Loud and clear. Alvin, thank you very much. My team, thank you. All right, brilliant. Hi, Evan. Long time no see. Okay, good. People trickling in as we get this started, but yeah, welcome. So, give give you a little taste of what you're going to see if you decide to sign up for my GRE course, which I'd love you to do at Target Test Prep. And yeah, so let's talk about some of the problems that we're going to look at, because one of the things I wanted to highlight in this session is the kind of cognitive traps that they could throw your way. And we're going to cover a few different topics, but the other thing to keep in mind is that we want to try to highlight strategically how they try to get you, right? Because it's not just about the math all the time. It's about, okay, the reasoning behind it and kind of avoiding some of the clear traps that they like to set. And I kind of want to just get started with a problem that we can do together. And this will be the first one, right? And it's more like a stats problem. Okay, so don't panic if you don't understand every part of this right away. But if you're not familiar with the way the GRE does these quant questions, right? This is called a quantitative comparison question. And you notice that we get two quantities. We got quantity A, the median of set N. We got quantity B, 30. And what we're supposed to do is kind of compare and contrast. We want to know which one is bigger. You notice answer choices A and B are always, okay, quantity A versus quantity B. But answer choice C, it could be that the two are equal for all we know. Or it could be answer choice D that we can't tell. And I think one of the things I always like to highlight is the idea that the answer could very well be D. A lot of people forget that it's possible that you can't determine this. So you're working on a problem and you get to a point where you realize, I can't really answer the question, and you think you did something wrong, but not necessarily. It could be that you did everything right and the answer is just D. I mean, you can't really tell. So that's a possibility we always want to be open to. And in this particular problem, we've got a set and we've got a group of numbers, and a couple of them are unknown. So we got X and Y in that mixed. And I don't know what's going on with the rest of them, right? X and Y could be anything, except that I know that the smallest value of the set is actually going to be Y. So if I were to actually put an ordering on this, and sometimes it helps just to kind of get your bearings by making something visual, right? I know Y is the smallest number in this list. And then I've got the other ones, 29, 30, 30, and 31, and 32. And then the tricky part is that X is going to be kind of a wild card here. I don't know exactly where it goes in this list, but I know it's going to go somewhere. Okay, and what we're being asked to compare is what the median of the set is. Now, don't forget, the median is the middle of an ordered list. So I have to put them in order first, and that's going to get me the median. So what I would want to do is open it up to you guys, and I'm not asking you to solve the problem all at once, obviously, but what could be a good step, a good first step to help us solve this? Or do you have any initial thoughts out of the gate? And you can hop on the mic or you can type in the chat. You can send me a private chat if you like. That's an option too. Okay, so I like what AT is saying here. Great. Thank you for the participation, right? We don't know X. Very much so. I would agree. We don't have any specified value for X. We really don't have a specified value for Y either. We just know it's the smallest one. So what does that mean for us? That's the question. You got to ask yourself, what does that mean in the context of this problem? Okay, I like this. And we're thinking about the ordering. AT is coming in and saying we can order it in several different ways. I know the median is going to be the exact geographic middle in this list. And we can order it in a number of different ways, because one of the things I could say is I got this X here. Well, does this X go over here? I know Y is the smallest, but X could be right there between the Y and the 29. I could put it somewhere in the middle, right? Or I could put it at the very end. It could be the biggest number in the list for all I know. So lots of different ways it could go. And yeah, this is kind of what Philip is saying, right? Put the X in different spots. Okay, and what does that kind of make you think at first glance if I think about it? I'm trying to figure out what the median of this list is. It's the middle of the ordered list. and I'm supposed to compare it to 30. So I could put X literally anywhere in this list, except for actually what I just did. I can't make it smaller than Y. Y is the smallest one. So what does that mean for me? Evan's got one idea. Make the median B, and Evan's saying the median won't change. Yeah, now I like the way that, so Evan's kind of cutting right to the heart of this, and Philip is saying, well, what would be kind of the first step here? Well, kind of test it out. Now, I think the thing that they're trying to get you here on is I said that you want to have D in mind. Answer choice D means that, you can't really tell. And your initial instinct might be to say that the answer is D here for sure, because I don't know where X is going here. I mean, it could be in any different part, right? So the thing you want to be careful of, though, is yeah, I don't know X, but this is where you want to pay attention to what I like to call, and anybody who's been in one of my classes knows about this. I call it QPUT-Q, which stands for question part of the question. Never forget what you're trying to solve for exactly, and it's the median. So what I can then do is I can go down here and I can say, all right, well, I know I don't know what X is, and I don't know exactly where it goes, but let's just start, like Philip was saying. Let's put it at the end of the list. Let's make it the biggest number. Okay, so X is the biggest number. I look at that case. And what exactly is the median in that list? AT's got one idea. Do we have a thumbs up? You can feel free to thumbs up if you agree, or hop on the mic if you disagree, or type in the chat. Philip is agreeing with AT. And you'll find very much that this is like how I like to run the class, right? I'll ask a lot of questions. You guys can feel free to hop on the chat or hop on the mic. Aha, okay. Okay, yep.
30.
Okay, so what this means is that I know that 30 is going to be the median, right? Because I've got a list of 7 numbers. And one way I can do this kind of visually is to say, okay, well, I know that this 30 is the geographic middle of the list because I got 3 numbers to the left and I got 3 numbers to the right, equal number of terms on either side. So I know the 30 is going to be right smack in the middle. So in this particular case, the median is 30. And then what I would say is, okay, well, I don't know exactly if X is there. It doesn't have to be the biggest number in the list, but I could do the exact same thing I was just doing and maybe put X over here in between the Y and the 29. So the X could go right here. I can't make it less than Y because I know Y is the smallest value in the set. But I do the exact same thing that I was just talking about. And I say, all right, well, I got 3 terms to the left of the middle and 3 terms to the right. And what I discover is the median's still 30. And the truth is, yeah, I mean, Evan was saying this a little bit earlier. I just tested 2 different situations. The median was still 30. And it turns out that no matter where I put X, the median is still 30. So the reason why I like to title this thing quantitative comparison traps is because they're trying to trap you into picking D. On other questions, the answer might be D, but you're getting you to say, okay, I don't know X, so the answer must be D. The problem is if I pay close attention to Q, question part of the question, I know the answer is actually C. These 2 quantities are going to be equal. It's always going to be 30, even though I don't know what X is. I don't even know what Y is. I just know it's the smallest. Kind of wild, right? Okay, so questions about that before we go to the next example? Oh yeah, so to clarify, when I was talking about question part of the question, so what question part of the question means is never forget as you're doing a problem exactly what you're trying to solve for, right? It sounds redundant, question part of the question, right? But I'm interested in comparing the median to 30. That's all that matters. So never forget, it's good to, as you're doing a problem, just kind of constantly come back and remind yourself exactly what it is you're trying to solve for. All right, Let's do some more stuff. And I said we were going to talk about some different topics, right? This one is a little bit more of a percent word problem. And what I'd like to hear from you guys is just kind of glancing at this after a little bit. I don't care if you're right or wrong. What I want to do is gauge what you think the correct answer is. In other words, what it feels like it should be. What do you think? And again, to stress, I'm not looking for a correct answer right away. I'm just asking about how it feels it should be. All right, Gonzalo is saying A. AT is pointing out we need to know the initial number of pines and willows. So I've got these decreases. I've got the 64%, I got the 50%, but what are those initial numbers?
Quantity B should be bigger. The answer is B.
Okay, so Toha is saying the answer is B. Philip says 50% means a minimum of 2. Okay. Now there's this idea of the minimum, right? So you see these percentages, and again, the first thing you might think is, okay, and it's true, I don't know exactly what the numbers are. How many pine trees am I talking about? How many willow trees am I talking about? But on a tougher problem like this, what they're trying to get you to realize, and maybe it'll be easy to overlook, is if this is 64%, there's a limited number of possibilities that I could actually have here for the numbers that this could be. So I know it decreased by 64%. And if I just said, okay, well, let's pretend for a moment that 100 is the number of pine trees, kind of using a test case here. Well, if it decreases by 64%, then I would go down by exactly 64 pine trees, and I'd be left with 36. Okay, but the question is, does it have to be exactly like that? Or does this give us an idea of where to go from here? It doesn't have to be 100 to 36. What else could it be? Aha, so Gonzalo was saying, what if I cut these numbers in half? And I'm assuming instead of 32, decrease by 32. Gotcha. Yeah. So I could say, well, I start with 50, right? Half of that. And that means that I would end up with half of 36. And you notice that it's kind of a proportion thing here. I could do 50, and then that goes down to 18. I'm decreasing by half of the 64. Aha, but Evan is saying I can actually do that one more time and say, okay, well, I got 25, and that could go down to 9. Sure. Now, my question is, once I get to this case right here, where I realize that the number of pine trees could be 25 and it can go down to 9, is that the minimum? Because you notice quantity A, question part of the question, Q pot Q. It's talking about the minimum number of pine trees. Can I take this down a notch further? Can I go down further from 25 and 9? Steven saying no, Philip saying no, 18 no. And why not? You guys are right. I can't go down any further than this. It's got to be an integer, first of all. Yep. And not that you have to do it exactly this way, but yeah, there we go. Steven's saying 25 is divisible by 5, but 9 is not, right? Put differently, and like I said, you don't have to do it this way, but 25 is, I know in terms of prime factorization, 25 is 5 squared, right? 9 is going to be 3 squared. They have different prime factors, right? 9 is a couple of 3s, 25 is a couple of 5s. This is about as low as I can go. I can't break it down any further. So guess what I just found out? The minimum number of possible pine trees actually is just 25. I can't go any lower than that. Now, somebody said something earlier. If I turn my attention to the willow trees for a moment, I know that it is decreased by 50%. Now that's a fancier way of saying what exactly? What's another way to think of decreasing by 50%? Yeah, Gonzalez says having it. If I decrease by half of it, so it's a fancier way of saying the number of willow trees is halved or divided by 2. Well, what does that mean about the minimum number of possible willow trees in the park? It's just 2. Yeah, it's pretty wild, right? If I decrease by 50%, in other words, if I divide by 2, what that guarantees is that the number of willow trees is definitely even or divisible by 2. Okay, well, it could be any number that's divisible by 2. So what's the minimum? It's 2. Okay, so you might think one way or the other to see where this is going, but as it turns out, the answer is A, because the minimum for A is 25, and that's bigger than 2. And that's really all that there is to this problem. And I like what AT is saying, right? And not E, but D, right? If you're thinking about GMAT, this is kind of akin to the data sufficiency where E corresponds to, I don't know. Yeah, no worries. But no, AT, your point still stands because, yeah, that's how ETS is evil. And that's kind of why I like to talk about this as quantitative comparison traps, because there are cognitive traps built into this. You look at that 64, you look at that 50, and you're like, oh, well, I don't know exactly what the number is for pine trees or willow trees. The answer's got to be D, right? Not so sure, right? I got to actually dive in and check it a little bit closer. Good job. Okay, moving right along to this one. And now I want to do something that has a little bit of more of an algebraic twist to it, but also there are some problems for which, yeah, it might be a little bit of algebra, but you also can tease it out with some logic. And I just want to kind of get it going and get you guys to tell me what you think. So I've got Carl, he's a collector of old quarters and nickels. And it says Carl were to add 12 quarters to his collection. He would have 3 times as many quarters as nickels. And I also know that Carl has more than 6 nickels. So let's unpack that a little bit because sometimes what you have to do before you even go to the quantities is unpack the question stem at the top. All right, so what do we take away from that? And I guess what I'm curious about is are you guys trying to come up with an equation or two or an inequality, or are you doing something else? Nice. Okay. So if I take the number of quarters, yeah, so I see a lot of people, Uzo, Philip, Evan, kind of getting around this idea that if I take the number of quarters and I add 12, so he's going to add 12 quarters to the collection, he's going to end up with 3 times as many quarters as nickels. So that is going to be equal to 3n. Take the number of nickels, triple it, and I get 12 plus the number of quarters. But I also have this interesting condition where I'm told that the number of nickels has to be greater than 6. And I'm being asked to compare. So I've kind of distilled the stuff at the top as much as it can go, right? Now I want to know, well, here's Q, and I want to compare Q to N. Interesting, right? So presumably maybe there's a way to combine these. But is that necessarily the best way to do it? Now, what I'm trying to gauge here is strategically speaking. I mean, the trap here that they're trying to set for you is you get wrapped up in the algebra. You try to do a bunch of funky stuff with the algebra, and it's a nightmare, et cetera, et cetera. But is there another way to do it? So for somebody who's seen this before, anybody know? Or if you don't know, AT's got one idea. Philip's got kind of a similar idea. And if you didn't see this before, if you haven't done a problem like this before, that's fine, right? But I wanted to give you guys a chance to chime in. And what AT and Philip are basically saying is, what if we just throw some numbers in that I know work and see what happens? because sometimes you can actually do a little bit of brute forcing. Doesn't have to be a ton, but the idea is you brute force a little bit and then see if you notice a pattern. So I know n has to be greater than 6. That's a pretty basic condition. So why don't I go ahead and just pretend for a moment that n is equal to 7. Okay, so my question to you guys is, if n is 7, at a bare minimum, 7, what does that make q? And all I would need to do, yeah, some of you are pointing out to me now, is solve this like I would a normal algebraic expression and say, well, q plus 12 is going to be equal to 3 times 7 now, which is 21. So what do I need to do to go from 12 to 21? I need to go ahead and make q 9. Yeah, it was just saying something similar. You could switch around the equation, do a little bit of a different form, still do the comparisons. Okay, but what do I look at here? I've got q equals 9 and n equals 7. So in this particular case, q is the bigger number. I would just have to be careful, because then I would say, okay, well, it worked once, but is q always going to be bigger than n? I can't just tell from one go, like just doing this one example, that that's always going to be the case. But let's kind of keep this process going and say, well, n is equal to 8. Now, if n is 8, then I got 3 times 8 on the right-hand side, and that's 24. So what do I have to bump 12 up by to get to 24? That's going to mean q is 12. And if I did this one more time, made n 9, 3 times 9 is 27, which means that q would end up being 15. Now, I said it's kind of a combination of brute force, but then seeing if you can establish a pattern here, because I look at these examples that I've just drawn up and anything interesting I notice. AT is saying I got multiples of 3 in the left column. I got the 9, the 12, and the 15. Sure. Anything else? And again, be very careful about q pot q, question part of the question. It's increments of 1. Joy's pointing out that I go up 1 on the nickels, and it looks like q goes up by 3 in response, which makes sense because I'm multiplying n by 3. Philip is saying the difference is growing. AT is saying it looks like q will always be bigger than, and I guess you mean n, right? So it looks to me like in each one of these cases, q is always bigger. But even further, I mean, even if I'm not quite sure of that, look at the difference between the numbers. If I go from 9 to 7, that is a difference of 2. If I go from 12 to 8, that is a difference of 4. And if I go from 15 to 9, that is a difference of 6. So it seems that not only is q always bigger, but as q gets bigger, the distance between q and n gets even bigger. So that is enough evidence for me, without doing any heavy lifting in terms of algebra, that yeah, the answer is going to be A. I'm always going to have more quarters than nickels with this condition. Q is always bigger than n. All right. Yeah, and you practice, but it is a little bit about concepts, because what they're trying to test your ability to do is think on the fly and figure out the best strategy for any given problem, right? So this one, we started with some algebra, but then we switched gears. And I think what I encourage my students to do in my class is, when you do problems, it's like, look for multiple ways to solve it. Even if you get a question correct and it took a little bit more time to solve it, I would say go back and look over it and say, is there a faster way to do it? Do I have to do it with a strict mathematical approach, or could I do something like this where I do it a little bit more intuitively and I kind of brute force it with some examples? All right, good work. Okay, so now what I'd like to do is actually, I'll look at this one together too. I think this one is a good one to talk about. But now we're getting into a little bit more algebra and what kind of traps are they laying us for us here potentially. And this is where I'll open it up to you guys once again and tell me, what do you think just initially looking at this? I don't care if you get it right or wrong, just what's your initial impression? Okay, AT's got one idea.
I would just S equals to 10.
Mm-hmm.
So quantity A will be 20. Mm-hmm. So it's the same. The two quantities are equal.
Two quantities equal, right? And Matina's saying the same thing, right? Now, I'm seeing some differing opinions here, but yeah, I think that the reason why we want to talk about this as a potential trap is that you look at an equation like x squared equals 10x, and it seems pretty straightforward what you're supposed to do here. You're supposed to divide by x. Okay, so I divide by x, and that gets me to, okay, x squared divided by x is equal to 10x divided by x, and that just gets me x is equal to 10. And I go ahead and I throw over here and plug in 10. 10 plus 10 is 20, so naturally they're equal, right? That's what they want us to think. The problem is, as several of you are pointing out in the chat, that's actually not the case. So what's the cognitive trap here? What are they trying to throw your way? Well, it's the idea that if you simply divide by x, you're overlooking that x could be 0. And you cannot divide by 0. So your job is to look at this and not fall into that cognitive trap and remind yourselves of those, common elements that could show up on like tests, common numbers like 0, 1, -1, common identity numbers. So algebraically, how would I want to tackle this instead? Well, what I'm kind of supposed to do here is say if I got x squared, and yeah, Sonia, question?
No, it's my own. Can I say what I think about the question?
Yeah, that's fine.
Okay, so what I did, so my answer is D, x squared minus 10x, and then that should give 0. So if we have x squared minus 10x, and then you take out x, you have either x equal to 0 or x minus 10 equal to 0. So depending on if you have 0 plus 10 or 10 plus 10, and that should give you a D.
Correct. Sonny's got it, and I see Stephen got this as well, and Uzo, a few others, right? Yeah, I mean, it's technically the most complete way to do this algebraically is to actually subtract 10x from both sides. I want to turn this into x squared minus 10x equals 0, because then, as Sonia pointed out, what I then do is factor out the x, and I get x times x minus 10. That's going to be equal to 0. Now it's pretty clear for me to see what's about to happen. If I multiply two quantities together and get 0, either the first quantity is equal to 0 or the second quantity is equal to 0. And that means that x could be 0 or it could be 10. But if I just go ahead and divide by x at the very beginning, I'm only going to get 10 as a possible solution. So if x is actually equal to 10, which it could be, then the answer would be C. 10 plus 10 is equal to 20. But if x is 0, then the answer is B. And what did I just find out? I got contradicting answers. And if I get contradicting answers, that's enough evidence for me. I know that the correct answer here has to be D. Good. All right, questions about that before we move forward? Yes, Gonzalo.
Hey, can you hear me okay?
I can.
Yeah, so basically, I mean, I haven't done a lot of these, and so my first thought was actually to take the square root so that you just have x on the left, or rather the absolute value of x left on the left.
Mm-hmm.
But of course, that doesn't make sense, right? So I'm supposed to recognize that I should subtract 10x equal to 0, and then factor.
But also to the point of what you actually did do, what you're supposed to do, I mean, in a very broad sense, how does this apply to other problems? We don't want to talk about just this one problem. But if you take the squared, so first of all, this is correct, what Gonzalo is saying to get into it. Aha, and yeah, AT, you're right. So if I square root both sides, like so, which might be my first instinct, that's understandable. And it is cool to know that the absolute value of x squared, keeping in mind that x itself could be negative, it's actually absolute value of x equals, and then I've got the square root of 10x. And I would look at that, and I should be able to tell pretty quickly that that's not the way I want to go, because it's actually made my life harder. And you'll develop a sense as you practice these problems, kind of like when you get to this point and you realize the calculations are more trouble than they're worth, there's got to be a simpler way to do it. And yeah, Evan's asking a good question. These answers that we've been going through, they are always the answers on quantitative comparison. Much like on data sufficiency on the GMAT, the answer choices are always the same. Same deal here for the GRE. It's always going to be quantity A, quantity B, equal, or I can't tell. Okay. So now what I'd like to do is just kind of let you guys loose on a question of your own. Take a few minutes to do it, but what I'd like you to do is when you get an answer, go ahead and hit me up in the private chat. So you should be able to go over to the chat and chat me privately to tell me what you think the correct answer is. And that is what I would like you guys to do for this question. All right, good luck. All right, let's talk about this. I really like the discussion you guys got going in the public and the private chat, right? And it's interesting because not surprisingly, I see every answer represented here. A, B, C, and D. Everybody chose at least one of those. So the question is, how do we actually tackle this here? Well, I'm looking at the average, And okay, well, the average of x, 2x, and 3x. So how do I tackle that? Let's just focus on quantity A for the moment.
You just add all of the numbers and divide it by 3.
Okay, and AT says, yeah, let's do the standard thing we know about averages, right? You don't have to have studied math in a while to remember that to get the average of a group of numbers, average is equal to the sum of the numbers, all divided by the number of terms. So what is the average then? It's going to be x plus 2x plus 3x. And I'm going to take that and I'm going to divide it by 3. So in the numerator, I end up getting 6x, 1 plus 2 plus 3, and I divide that by 3. So I have figured out that the average is 2x. And it's much the same over here for the average, right? I'm going to add all these numbers and I'm going to divide it by 3. So in the top, I've got 3 x's. I've got 1 plus 2, which is 3. And I'm going to divide that by 3. And then what I might notice is, right, if I actually add stuff up and I divide by the same number, I can go ahead and split up the fraction. This is going to be the same thing as 3x over 3 plus 3 over 3, which is just going to be x plus 1. So I've got 2x over here for quantity A, and I've got x plus 1. And these are the two quantities I am being asked to compare. Now, this is where we had a little bit of a difference of opinion. So I want to hear the arguments now as to how we're going to tackle this. So what do we think? Which one is bigger? Do we know A is bigger, B is bigger? Are they equal, or can we not tell?
Well, here you can technically just choose a number for x. So let's say like you take 1 for x, you'll have what? You have 2 and 2. And if you have 2, for example, for x, you have 4 and 3. So in this case, you can clearly see that there's a difference. And we don't necessarily know which one is going to be bigger depending on the situation.
And this is one option you can use. So AT is saying, yeah, and Philip is saying the same thing. So we can test some easy numbers. I tend to personally stay away from 1 and 0. On this one, it works fine, right? But in general, it can lead to duplicates in answer choices if you have like a regular problem. So, but it doesn't matter because if I start with 2 and I say x is equal to 2, well, then what I would get is 2 times 2 is 4. And that's going to be compared to 3, right? But in this case, I will say that actually 1 is fine. I mean, normally you might not want to do this. So it could be that we have 4 and 3 on one side or the other. If I plug in x equals 2, I'm going to move that so we can keep track of this. So here we have x equals 2, and we get 4 and 3. But if x were equal to 1, then what would happen is I would get 2 on this side, and I would also get 2 over here. And I just produced contradicting answer choices, right? Quantity A is bigger in the first example, but they're equal in the second, which is enough for me to see that the answer has to be D here. Now that's if you tested the numbers. You are not required to do that. The other thing you can do is if you just want to take a more straightforward approach with the numbers themselves, I could say, okay, well, 2x, doubling the number, is that going to be bigger than, increasing the number by 1? Well, not necessarily. I mean, it could be, but I don't know that for a fact. I know we did do the average choice, so that's what I was doing with when I got the 2x and we got the x plus 1. So we're comparing the averages. The average in quantity A was 2x. The average in quantity B was x plus 1. So I'm comparing those averages. I need to compare these numbers. Okay. And so, yeah, not necessarily. Joy's saying I got the answer without doing the average. Not necessarily if you can figure out that really what's missing here, or what should make you suspect the answer is D, is that I don't know what X is, and X could be a number of different things. Then you can go test it just to be sure. But at the same time, you want to be careful, right? Because we picked 1, we picked 2, et cetera, but is there any real restriction on what X could be? That's a question for all you guys. Do I have any restriction on what X could be? I don't. So what kind of number could X be? everything, including what types of numbers. What types of numbers do I have to keep in mind on problems? Could be decimals, as Joy says. It could be negatives. Yeah, exactly. In fact, a good rule of thumb is if you know any number is in play, you want to think about things like, okay, well, it could be bigger than 1. It could be that we're dealing with positive fractions. It could be that we're dealing with negative fractions. It could be that we're dealing with numbers that are less than -1. Or in some instances, it could be the numbers themselves. You could have 1, you could have 0, and you can have -1. And you don't want to overlook those. And I like what Uzo is doing too, right? So what Uzo did is kind of a strategic way you can do that is just to say, okay, well, let us pretend the answer is A. So Uzo is saying, okay, well, if that's the case, I would have 2x is greater than x plus 1. Is that definitely true? Well, I subtract x from both sides and I get x is greater than 1. But the problem is that is not necessarily true. I don't have any restriction on x. Could be bigger than 1, but it could be equal to 1. It could be a fraction. It could be a negative number. So then I would say, okay, well, yeah, this doesn't actually hold necessarily. It doesn't have to be A. And that's another way to show that the answer is D. I like this. Good strategic stuff you're coming up with. All right. So we will move on. Give you guys another crack at a problem on your own. You guys are doing pretty well now. Okay, what do we think? Good luck. Okay, so I like what I'm seeing coming into the chat now. The good news is the majority of you who are actually responding here are getting this correct. Okay, so there's a number of different ways that you can do this. Yeah, and I'm seeing, yeah, I'm going to talk about several different ways you could attack this, but what's the trap, right? This is all about traps. Well, if I look at x plus y over x equals 4 over 3, now it's x red candies and y green candies. So my question is, what did you guys do with that equation? Did you guys kind of attack it at the outset? And if so, what did you do? Attack at the outset, okay? Yeah, what if I actually just simplify that? What if I actually cross multiply, right? So I could take kind of a standard algebraic approach here and just say, okay, well, I'm going to take that 3, I'm going to multiply it by the x plus y. Yep. Multiply the x plus, times 4. And so what I get here is an equation that says 4x is equal to 3x plus 3y, doing the cross multiplication. And then once I've done that, I can subtract 3x from both sides and just get x equals 3y. So what that tells me essentially is that whatever y is, the number of green candies, I just triple it and I get the number of red candies. Another way to look at it is there's a ratio involved here. The ratio of x to y, if I divide both sides by y, is 3 to 1. 3 times as many, right? Now the trap here that you could possibly fall into, and it looks like I don't think anybody fell into this one. Nope. So what I was thinking of here is the idea that I don't know the exact values of x and y, right? This is a ratio, not exact values. So you might look at this and say, well, the answer has to be D because I don't know the exact number. But the problem is, what's Q pot Q all about? Question part of the question, the probability. And probability, I don't care how complicated it gets, it's always, 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 probability is always desired over total. And that can be in the form of a fraction. So what I'm supposed to realize here is that if it is 3 parts x to 1 part y, that means that the total, whatever it is, it's going to have to be a multiple of 4. And it's going to have to be in 4 parts. Well, if I'm selecting a red candy from the jar and I want to know the total, okay, well, it doesn't matter what the individual numbers are. It's always going to be 3 parts x to 4 parts total. So the probability is always 3/4. It's always going to be 75% or 3/4. And I also know that 3/4 is going to be bigger than 2/3. So that's one way, kind of the standard algebraic way to do it, or we can kind of crunch it down and see that quantity A is going to be bigger. Now, some other people are pointing out that there is a nice conceptual shortcut you can take here. If I take the original equation and I flip it, what I get is x over x plus y is equal to 3 over 4. So those of you who did it that way, what are we looking at here? Instead of doing this algebraically, I can kind of size it up conceptually. What's going on here? Yeah, it is just the equation for A. It's easy to get wrapped up in the algebra right away and not notice that what am I dealing with here? Actually, I'll just put it equals. Well, the x in the numerator, that is the number of reds. And x plus y, that is the total. That is exactly what I'm looking for, right? The probability of selecting a red. So I've got it. I've got my 3/4 just like that. Yeah, and I'm seeing some people compare this to kind of like the data sufficiency on GMAT, right? It's one fewer answer choice. And sometimes the math can be a little bit more straightforward. For sure. All right, so any last questions before we move on from this? All right, moving forward. Next one, little geometry. This is unlike the GMAT. So geometry is still in big part on the GRE. Good luck with this. We'll be back. Nice. I really like the comments you guys are coming in with here. And you know, a lot of you who are answering are not following, or you're not following. I can't talk. Not falling for the trap. Okay. Okay, and let me know if you still have a blank screen. Looks like for the most part we're all right. But yeah, I like the logic you guys are telling me here. So the thing we have here is we know that z is greater than 60. Okay, so if you wanted to recreate the diagram on your scratch work, which I think is a good idea, so you can look at it yourself, then you would say, okay, I know that this is bigger than 60. But the other thing I know is that I've got some equal sides here. I know that AC is equal to BC. And that means that the angles opposite those two sides are going to be equal as well. So y and x are going to be equal. If you didn't know about that property before, now you know it. Equal sides imply equal opposite angles. So I know that x and y are the same in terms of degree measures, right? But I also know that z is greater than 60, which means what? Well, as some of you are pointing out, what that means is if z is greater than 60, then that means the sum of the other two angles, x and y, have to be less than 120. Because all the angles in a triangle, I know that everything adds up to 180 for a triangle. So if I bump up z beyond 60, that means I've got to bump x plus y down. It's going to be below 120. And if I combine that with what I know here, I know it's exactly the same thing, right? Now, quantity A, the question part of the question, is all about x. So I might as well just rewrite this to say x plus x is less than 120, since y and x are the same. And that means that 2x is less than 120, or x is less than 60. And now I have everything I need, because once I've got that all in place, I know that even though I don't know what x and z are individually, the only thing I care about in the context of this question is which is bigger. And if z is bigger than 60 while x is smaller than 60, no two ways about it, boom. I know that quantity B is going to be bigger here. Good. So most of you didn't fall for that cognitive trap. Nice. So I think this is a good place to kind of cut it short here because I want to talk about the course a little bit. I will hope to see you guys in the course in the coming weeks. Yeah, and if you have to take off, that's cool. But I also wanted to give you guys the link to sign up for the class. It'll be 40 hours of instruction with yours truly. I've been doing this for quite a while, 16 years. Love to take standardized tests. I'm one of those crazy people. That's why I do this. And yeah, I just love to solve problems, and I'd love to be interactive in the classroom, so it won't be just like a straight lecture. It'll be a lot of participation. And I like to introduce you to different strategies that kind of go beyond the course, because you'll have access to the TTP course. That's also something that's cool, is you'll have access to the course as part of the deal. You won't have to pay extra for that. And yeah, the cost is, I'll put this, $999. Okay. And that's for the course, but you also get 6 months of access to the self-study course. So you'll be able to use that. And that's going to be an integral component to the course as well. And we also have a Slack channel where we'll keep in touch. You can send me messages via the Slack channel. And yeah, it's a flat payment right out of the gate. So you pay it up front. Yeah, $999 for the whole course. The course is not 6 months. So the course it's 40 hours, so 20 classes individually. So you're talking more about a span of like, a few months, 2.5, 3 months. But you do get access to the self-study course for 6 months. And if you've already done the whole TTP course, then yeah, this will be kind of a nice compendium to it. You'll still get access to, extended access to the TTP course, and you can redo the problems. You can redo some of the quizzes. And no. So to clarify, the course is not just only math. You will get access to verbal as well. I mean, the course I do is not just a quant course, it's a verbal course too. And we also have a vocabulary bank, a set of flashcards that you can use. guess I'll throw, see if I can copy this and paste it, but a link, or is it not going to let me do that? Nope, it's being mean. It's not going to let me do that. So I'll just type it here in case you need to see it up here. There we go. Yeah, feel free to ask any questions you like before we wrap things up. That's why I wanted to stop a little bit short of the hour.
No questions from me, Rich, but thank you so much.
You're welcome.
Have a good one.
Yeah, you too. You guys are very welcome. Philip, Jing, Ozu, you're welcome. Or Uzo, excuse me. Ah, that's what I like to hear. Toha says I make it easy. Well, that's the goal, right? And my goal is to get you guys to think in the same way, right? And show you that it's not just always about complicated math. You're very welcome. Seeing some people in the private chat, nice. Okay, cool. Well, I'm going to hop off the mic in the video. I'll stay around for a few more minutes in case you guys have any other questions. But yeah, hope to see you guys in my class starting in the next week or so. And yeah, have a great day. See you guys later.